talk about real quickly the parent functions and their graphs. Okay, so this parent functions and their graphs is really coming from the previous section, section 1.1. That's what you did yesterday as a whole class and in some small groups. So parent functions, f of x equals the absolute value of x, and f of x equals x squared. You should know, and this should be sticking with us, all absolute value graphs should look like V-shaped graphs. All quadratic graphs with a square should look like a parabola. So I'm going to plot some points that we would have plotted on our parent function for the absolute value, like 0, 0, 1, 1, 2, 2, 3, 3. And then we would do negative 1, 1, negative 2, 2, negative 3, 3, and that gets us our V-shaped graph. If you want to include in your notes a table of values, you could make a table of values for yourself. Negative 2, negative 1, 0, 1, 2 gives me 2, 1, 0, 1, 2. So parent function is f of x equals absolute value of x. The parent graph is the V, the absolute value graph, centered at 0, 0. And we had also talked about and labeled yesterday our domain. X was equal to all real numbers, and our range, y was greater than or equal to 0. So that's true for the parent graph. And then I'm also going to graph my quadratic parent graph over here on the side. If you want, you could create a table of values, x and f of x. We did this yesterday as a whole class, so I'm going to move fairly quickly. I'll put in negative 2, negative 1, 0, 1, and 2, and that gave us 4, 1, 0, 1, and 4. So I'm going to plot those points. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. I'm going to have some Algebra 2 students who, on some problems, may draw a quadratic that looks like a V. And you'll have to be very careful. I'll take off a point for that. All quadratics should look like a curved U. It should not be pointy. Even if it's very skinny. You draw it round. So make sure when you draw your parent graph that you're taking the time to draw something that curves at the vertex, okay? Make sure it curves. It forms a U. And domain and range are the same for the quadratic, which makes sense because they're very similar. They have a minimum there at the vertex at 0, 0, and then they both go up. So their domain and range are the same. So again, that's really a review from section 1.1. We had talked about that yesterday before you went into your group work, okay? Now, we're going to start talking about the transformations for those graphs. So this is kind of like what you were doing at the very beginning of class when you went to the different stations. Before we do that, I just want to review function notation. And you are going to get your quizzes back at the end of the period today. So this is a good review for some people who might need a little reminder about function notation. We talked about it yesterday, right? F of x is just a fancy way to write y. Instead of saying y equals 2x plus 3, we can write f of x equals 2x plus 3. The benefit of writing in function notation, which we're going to do in Algebra 2, and you'll do in pre-calculus and on, is that then I can write something like this, f of 2. And this you saw on your quiz from the summer packet. Notice that the change from f of x to f of 2 is that we've replaced the x with a 2. So then in the equation, we're going to replace x with 2. So all it's telling you to do is directly substitute that value in for x and evaluate. Or simplify, whatever. So then we know that f of 2 is equal to 4 plus 3, which is 7. 2 is our x, 7 is our y, because f of x is just a fancy way to write y. So then we now know an ordered pair on our graph. And anyone who looks at that and sees f of 2 equals 7 knows that 7 is the y value when x is 2. If I'm just plugging 2 into the original y equals 2x plus 3, then I'm going to write something that says y equals 7. But all you know is that y equals 7. You don't necessarily immediately see what x also is. So you don't get that whole ordered pair piece. Now, you could figure it out if you backtracked in the work, but as mathematicians, we like to see it all together. So it's just being extra informative. Okay. So I'm going to use function notations. All right, so we're going to do transformations and function notations. Oops. Hang on. That's always a pain. Okay. Transformations and function notations. The first set of transformations are the translations. Translations, if you'll remember from geometry, and I always remember this because I think translations has an SL, and SL leads me to slide. Okay, so it's my sliding on the coordinate plane, left, right, up, down. Those are the directions I can move. In function notation, if I want to move to the right, that's going to be f of x minus h. F of x minus h moves me to the right. F of x plus h moves me to the left. Notice that those h's, minus h or plus h, are in a set of parentheses. So they're right next to the x. They need to be included inside of an absolute value with the x, inside of the quadratic, so what's being squared with the x. I also always give my students a reminder that h looks like the opposite. So when you plug into function notation, x minus h actually goes to the right when normally negative is to the left. Do you understand what I'm saying there? And x plus h goes to the left, even though plus would normally go to the right. So h is like the opposite of what you think it will be. It's weird. To write function notation for moving your graph up, that's f of x plus k, and down is f of x minus k. So this kind of goes along with what Luke was saying about the vertex. You notice that the vertex of the parabola or the vertex of the V shape was happening at hk, and h would have looked like the opposite in the equation. But that change in the vertex is a slide left, right, up, down on my graph, wherever that may be. So those are our transformations. Jacob.
Go to the restroom to put my contact in.
Yes. Okay, we also have reflections, and we talked about that. I can't remember who told me about the reflection. Jacob. Signing out. Okay. You can have reflections in the x-axis or reflections in the y-axis. The most common reflection, or probably the reflection you're most familiar with, is the x-axis reflection. We reflect in the x-axis so that it flips, and it's a V shape opening down or a U shape opening down. So the x-axis reflection is like what Jacob described when we have a negative in front of the function. Okay, so that negative was in where the a value was. A y-axis reflection, we're going to flip over the y-axis, and if you imagine a point, let's say I have the point 3, 2. If I were to reflect a single point 3, 2 over the y-axis, my new ordered pair is negative 3, 2. So the only thing that changes in that reflection is x. So instead of saying negative f of x, which is the opposite y, and makes us flip over, we're going to do f of negative x. I gotta take a minute and look in your text. So for stretches and shrinks, I use the same number or same letter as you guys will. Hang on 1 second. Okay, they use A, good. Okay, so then there are the stretches and the shrinks, and those are the ones where your graph gets wider or narrower. Okay, but we're going to try to use the vocabulary stretch and shrink because we're also going to be learning new functions later on that really can't be described as wide and narrow or like parabolas and these. So we're going to use this phrase vertical stretch and vertical shrink. So a vertical stretch would be A times f of x when the absolute value of A is greater than 1. And a vertical shrink would be A times f of x when the absolute value of A is between 0 and 1. Now the reason why I put absolute value there is because we want to look just at the number A, not at the positive or negative. Positive or negative is going to tell us if it opens up or if it opens down. The value of A, its absolute value, will tell us if it's stretched or shrunk. Notice that neither of these say or equals to 1. If it's equal to 1, there is no stretch or shrink. It's normal size. And we're not going to do the rotation, but let's add to our stretches and shrink. We'll put in horizontal stretch and horizontal shrink. And those things happen horizontally. So horizontally is with your x. So instead of having A multiplied by y, then A multiplies by x. So we're going to have the function of A times x when 0 is less than the absolute value of A, which is less than 1, or f of A times x when absolute value of A is greater than 1. And just like the h value, which I always think is the opposite of what I think it should be. Like when it's plus, it goes left. When it's minus, it goes right. The same thing is true for horizontal and stretch and shrink. It horizontally stretches when A is less than 1, but it horizontally shrinks when A is bigger than 1, which is like the opposite of what I think it should do. And we're going to do stretches and shrinks tomorrow. Those are probably like the big troublesome spots here in transformations. Does anybody remember doing vertical and horizontal stretch and shrink? A little bit. You don't have like any kind of PTSD or anything from it, do you? Okay. So that's going to be like, that can be really tricky for some people. So we're going to look at stretches and shrinks tomorrow separately, but we'll at least have them in our notes for today. Okay. And if you want to make a note, horizontal stretch or shrink is kind of the opposite of what you think it will do. And we'll talk more about that tomorrow too. Okay. Question? Just oohing and awing over all of the math. I get it. It's exciting. Abby's enthusiastically shaking her head. Yes, it is so exciting. Okay. So I'm going to put you to a challenge here in your small groups. can you look at the two equations on the screen right now and tell me what's happening to the graph? So what type of transformations are you seeing? So you're thinking about, would I describe it as a translation, left, right, up, down? Is there some kind of reflection in the x-axis and the y-axis? Is there, and today I would just do vertical stretch or shrink. So just looking at an equation, and it's different than the parent graph, it's like what you did yesterday. Can you and your group members come up with some transformations that would be happening to the graph? Go ahead and take a chat with your group members. Okay. That's being multiplied in the front. So all the function notations zero down. We have negative f of x. And then we have negative. So multiply it here. Out front. So there's
Oh, because we're not talking about those graphs.
Yeah, but there's minus two.
Does that number if it's less than 1? And it's less than 1? Well, then it's dealing with horizontal.
So you guys feel confident on this situation?
We'll just say it's sliding.
Yeah, she would. Are we fine, okay, keep questions about what it is? Can you give me a transformation for the first one? Okay, because in the parentheses, so in the absolute values, it says x minus 2, which is that x minus 8. So and build off of that, so plus 3. Are we feeling confident with our tasks?
I'm telling you,
The questions? Yeah?
it's horizontally. It's horizontally. No, but
Yeah, cause it's
It's
not
like,
it's
yeah.
multiplied by x, so that's.
Yeah, well,
Good, totally.
Everybody
just pick one number at a time. Look at that one. Is the one that which translation
That's what my I get a C. I'm considering myself B. You're expecting. One of them like.
Sorry, I feel like well, I was
It's like.
Yeah.
I was good at it, but
I got like the first one, but it was proofs. I just kind of wrote down like because it does. Everything was the definition of multiplication, the definition of division. The definition. I hate when I get that.
It's a definition of something. You would have it.
Yeah, you could just put it there and it's fine.
Yeah, look at the second one back. You make it really difficult.
So since it has the negative on the outside, wouldn't it be a reflection?
Yeah, it should be x-axis.
Yeah, it'll be
And then it would also be moving to the left because it's plus. And then minus 2, so then you would go down. So it would go left, down, and reflection in x.
So like if I was looking at the first one, this is one half.
I know, right? It's like, oh, yeah, take
That's high. No, that's a shrink. That's not vertical.
No.
This is
B.
Oh, H, this is H. That's odd. That's not a lot. No. I never do that. Okay, so that's odd.
Okay, let's come together.
We just skipped over.
Avery, give me a transformation for absolute value graph from its parent graph. Give me one of the transformations of this absolute value graph from its parent graph that you and your group talked about. And how many? Right. What's that? 2. Yes. Okay. So we have x minus 2, which is like inside the absolute value. So it's like inside the parentheses, it's like our x minus h, which in function notation, function of x minus h moves us right h units. So we would say right 2 units. Okay. Izzy, give me another transformation.
We have translation up 3.
Up 3. Okay, Noah, give me a third. Okay, so vertical stretches and shrinks, we'll only look at those today. They do what you think they'll do. So if you vertically shrink it, it's gonna like push it out and it makes it shorter. So the 1/2 is smaller, so it shrinks it, is what I should say. But like if you imagine that, can you imagine like putting your picture in paint and you like push up on your picture and your face just goes like out, right? So your picture has nowhere else to go. So that's what happens to the graph. If you push that V up, it has nowhere to go but out, so it looks wider. Okay, so it's a vertical shrink. Okay, excellent. And we'll say vertical shrink of 1/2 technically. Okay, so vertical shrink of 1/2. All right, Nathan, give me a transformation for the f of x equals x squared.
Okay, so it went down
Okay, just tell me how many. Down
by 2.
2. Excellent. Mason, give me another transformation.
Reflect off the x-axis.
Reflect in the x-axis. Very good. That's the negative out front. So it's going to now be a parabola that opens down. Great. And Elise, give me the last one. So we've attacked the 2. We've attacked the negative. What other number is in the mix there? The +1. That's in the parentheses. Look at your notes. F of x plus h. Find that in your notes. When it's in parentheses and it's got a plus, which direction does it move? Left h units, I should have said. So left 1. Okay. All right. So each of those had 3. Excellent. Does anybody have any questions on how we're pulling that out? Okay, next set of problems here. Now, we're going to write new functions. I'm going to move this up. Okay. So we're going to write a function, a new function g, whose graph would represent the indicated transformation of the function x. Okay, so I'm going to walk through number 1 with you. F of x equals 3x minus 2. So that's the function. We want to go 5 units up. So how do you get 5 units up? You add 5. Inside with x, outside? Outside. Okay. So we're going to say g of x equals 3x minus 2 plus 5, and then simplify. G of x equals 3x plus 3. These are like terms. There you go. You're done. Okay. Number 2. F of x equals the absolute value of x minus 1 minus 3. We want to go 4 units to the right. How do you move to the right? Aiden? Subtract inside with the x, right? That's the f of x minus h. It's the opposite of what you think it will do. So we're going to say g of x equals the absolute value of x minus 1, that's there, minus 4, and then finish out the function minus 3. So that will be g of x equals the absolute value of x minus 5 minus 3. You could go straight to the answer. Yeah, if you could do that. I mean, obviously in notes, I'm going to show how I got my answers. Otherwise, I get people who check notes online and they're like, I don't know how you got this. So, of course, I'm going to show my work. Would I show my work on my quiz or test? Absolutely, so I could get partial credit. What if you add wrong? Otherwise, you lose all your points. Okay, now real quick, I want to just discuss the reflection in the x-axis versus reflection in the y-axis. Where does the negative go if you're reflecting in the x-axis? Inside, outside?
Outside.
Outside. So this would just be g of x equals negative, and then you've got to reflect the whole thing here. So it would be negative absolute value of x plus 2 minus 1. And then because you're making the whole thing negative, this negative in front of the absolute value becomes positive. You don't have to worry about the stuff in the absolute value, but minus 1 also becomes positive. I worry about people who don't show their work on that one, not making plus 1. Okay? So that would be making the whole thing opposite. So it would be absolute value of x plus 2 plus 1. Where does the negative go if you're reflecting in the y-axis? Inside with the x. So this will be g of x equals 1/2 negative x plus 1. And in this case, I don't have an absolute value or a quadratic, it's just a linear function. I could multiply those together and make it negative 1/2 x. And then this one will stay plus 1 because I'm not making the whole thing negative. All right. Any questions about what I'm doing up there? Okay, so you'll be asked to do that on your homework assignment as well. And you can look back to your function notation. Where do those numbers or those negatives belong? All right, we'll come back to the fill out your book card. This is your homework. Will you pull out your gold sheet for me? Okay, your gold sheet has really like the same assignment for today and tomorrow. And I probably should have changed that because I really don't want you to do anything beyond number 16 because that's the vertical and horizontal stretch and shrinks. And I want to talk more about horizontal stretch and shrinks as a whole in order. So you can cross off on today's 17 all the way to 43. We're going to do that tomorrow. Tonight, your homework basically is 3 through 16. Yes, Luke?
We have to do number 9.
It is not bolded or underlined, so it's not required. But if you're on a roll, you could do it. So that's happening. Okay. Now, we're going to talk about books here.